When do these keys happen? Well, if you remember, initially we have the access point or the controller and the client, and both of them have the PMK, either because it's a pre-shared key or because you derive the PMK through the authentication via the authentication server, and the server returns the PMK to the access point and the client already has it. So what happens at that point is what we call the four-way handshake. And it happens both in WPAV1 and WPAV2, but with a variation. So let's look at what happens in WPAV2. Remember, everything we saw before about 822.1x still applies before, right? Except if you have a pre-shared key, in which case the key is already there. But then at the end of the authentication with the reduced server, when everybody has the PMK, this is what happens. We have a number that is a random number, which we call number ones. That's the name that you see on the screen, that is generated by the access point. This number ones is going to be communicated to the client. That client is also going to generate a supplicant number ones, and that's why you see the name here. And the good thing is that the client is going to send that number ones in an encrypted manner back to the access point, and is going to sign that frame with a message integrity check. And that message integrity check is going to be calculation of the frame derived from the knowledge of the PMK. This is important because that means that that message integrity check, that sort of a checksum of the frame, is going to be using the PMK. So that means that it proves that the client has the right PMK. So what the access point is going to do here is going to read the frame, read this number ones, and also verify that the checksum that was done during the key matches the checksum that the AP would find with its own copy of the PMK. And if they match, it means that the client has the PMK. So on that point, the AP is safe that the client has the right PMK and we can continue. So the access point is going to generate the pairwise transient key from the PMK, and then it's going to let the client do the same on its other side. Once we have that, the access point is going to use that pairwise transient key to encrypt the GTK and also do a checksum on that frame using also the message integrity check. And it's going to send that encrypted frame down to the client. So here we have also the message integrity check coming back to the client. So the first thing the client is going to do is to check that checksum, that MIC, and see if using the same PMK, the client would find the same MIC. And if it does, then it proves that the access point has the right PMK. So you see, initially we have this number, random number generation that is being sent down. The announce is sent in the clear. The client is going to use that number to generate a number that is going to be used with its S-nonce to encrypt traffic on the way up. And that's going to allow the AP to verify that the client has the right PMK. And then when the AP is going to send down the group temporal key and also signing it somehow with this MIC, the client is going on its side to verify with its own PMK that the access point also has the right PMK. So on that point, both of them are comfortable that the other side has the PMK as well. They know both have it. And on top of that, the client also has the group temporal key. That allows them to communicate. So the client is simply going to return a fourth packet that is going to tell the AP, all good, I got the group key, I got it installed, and also I could validate that you have the PMK, we're good. From that on, they can use the PTK to generate encrypted traffic, and of course the GTK can be used to send broadcast traffic to everyone, including to that client. At any point of the communication, if they need to change a PTK, they can just use that encrypted negotiation they had before to say, let's move to another number ones, another S-nonce, and generate a new PTK from my PMK, and then communicate that value across the same mechanism to continue the session using a new key. This is in WPAV2. In WPAV1, the process was slightly different. We're also starting from the same logic where we had these number ones that is used by the client. The client is going to generate this number ones as well, and is going to return this number ones with a message integrity check as well. What changes here is that there is on top of that an information element that says, hey, I'm using WPAV1. We don't have that anymore in WPAV2. The process is the same so far, and the access point is also going to use that number ones it has plus the S number ones from the client, supplicant number ones, to generate the PTK. At the same time, the AP is also going to use the message integrity check to verify that the client has the PMK. But then the difference is that at this point, the AP is going to return back a message integrity check on simply a WPAV1 information element. There is no group key here. This allows the client to check the MIC and also verify that the MIC shows that the AP also has the right PMK. So that sort of completes the negotiation as well. So the client is able to say, yep, I got the key installed on my side, unicast key this time, and I validated that you do have the right MIC. So you see in WPAV1, it's kind of the same choreography, but we don't send the group key yet. We need a second negotiation, a sort of two-way handshake as we call it, where this time we're going to send the GTK over the encrypted frame, and then the client is going to return that it did install the GTK correctly. So it's the same process, but we're wasting 2 more frames. We make it more compact in WPAV2 by sending the group key directly at the 3rd frame instead of doing the unicast negotiation first and then going into the multicast and then going into the group key negotiation. You don't need to master these differences, but you need to recognize that WPAV1 is different slightly in its choreography from WPAV2. In any case, today, what do you want to use? WPAV2. WPAV1 has done its job. It's not something you should deploy anymore.